This is 8.2. We're going to be talking a little bit about sine and cosine curves in this section. We already did the basic sine curves and cosine curves in the last chapter, and you can kind of see those here where you can see with the pi, the negative pi halves, the negative 3 pi halves, all of the radians and the degrees that we deal with. And it's really important for you to understand what the basic sine and cosine curves start like and what they look like. So obviously they go anywhere between 1 and -1 as a y value. The sine curve starts at 0, increases. So really here are the major points that you're going to really want to know. You need to know when it's 0. You need to know when it's 1 or what it's at pi halves. You need to know that it's pi, what it's at 3 pi over 2. And then what it's at 2 pi, and then obviously the same thing in the other direction. Those are going to be the very important parts that you need to know. Just thinking of the unit circle when we draw it, basically the points that you need to know are all of these points. It's all the ones that are on the axes. And that's going to be really important for what we do in today's section. So let's get into talking about some of the terminology that we need to know. So if you see a change in any type of sine function, the a in front, that's usually a number, it will be a number, that is considered the amplitude. The amplitude is basically what you have is it's basically the distance from the top of your sine function down to the middle of the sine function, not the entire thing. So normally your amplitude is going to be just 1 until you put a number in front of it. So whatever that number is, it changes what the height of those little, I guess, of the cycle there, or that, you know, the hill, if you want to call it. Okay, but keep in mind it only goes down halfway. It's not the entire thing. So this is not equal to 2, it's equal to 1. The amplitude's from here to there. Okay, the frequency, that is going to be the b. So anytime you have a number in front of your x or anything in front of your x, that's the frequency. The frequency can be best described as so if I asked you what the normal cycle of a sine function is, hopefully you would say it's 2 pi or 360 degrees. In other words, that means that it goes through an entire period or an entire cycle in 2 pi. The frequency is going to be the number of times that you see that function go through a cycle within a 2 pi period or 2 pi cycle. So if the frequency is 2, it means that instead of you seeing it going up, down, and up in 2 pi, you would see it go up, down, up in 2 pi. So basically it would go through 2 full cycles before you got to 2 pi. Okay, and we'll kind of get into that in a little bit. And then the period is basically how long it takes for it to go through one cycle. So what we do there is we take 2 pi and divide it by whatever the frequency is. So whatever that number is out front, that will help us figure out what the period is. So we'll know how long it's going to take to go through one full cycle. Okay, so let's look at this example. Real simple. Identify the amplitude, frequency, and period. Well, the amplitude is just the number that's out front. It will always be a positive number. So in this case, it's 5. Then we go to the frequency. The frequency in this case is just going to be the number in front of our x, which is 4. And then the period, sorry, you can't really read that. The period is equal to 2 pi divided by whatever the frequency is. So 2 pi divided by 4. And then we can reduce this to be pi over 2. So the period here is pi over 2. And again, what that means is, let's talk about this. So that means that the height of each of those hills is going to be 5. From the middle to the top will be 5. The frequency means that we will go in a 2 pi cycle, or from 0 to 2 pi, our sine function will go through 4 full cycles before it gets to 2 pi, which really means that each cycle is only going to be pi halves long. So obviously you can think about that. If each period or each cycle is only pi halves long, of course it would go through 4 cycles before you get all the way to 2 pi. Okay, so that's basically, we want to get familiar with these terms and understanding how these sine functions and cosine functions are going to change. Okay, so I want you to try this one on your own. Don't worry about this graph at the bottom. We're going to do something with that after you do this one on your own. So I just want you to identify the amplitude, frequency, and period of this. So try that on your own. Let's see how it goes. Your amplitude here should have been 3. Remember, not -3, it should be a positive 3. Frequency is just 0.5, and the period, if you do 2 pi divided by 0.5, you can reduce that to be 4 pi. So that means that it would take 4 pi for us to go through an entire cycle. All right, so what I want to do is I want to take this graph and I want to show you how we would actually graph it. Take this function and actually graph it. So there's one thing that we have not talked about, and that's this negative sign. So what does that negative sign do? Well, it's real simple actually. If you look at an original cosine curve starts at 3. So if I were to put 3 cosine, then that means it would start at 3. If I put negative 3 cosine, then it just means that your entire graph is going to flip completely. So what we would do to start this is, the first thing we want to look at is we want to look at what is our amplitude, okay, and then is it positive or negative? Well, we're dealing with a cosine, so normally it would start at 1, but because we have a 3, it would then start at 3. Because it's negative 3, it's going to start at negative 3. So our very first point that we're going to plot is going to be negative 3. Now, as I was saying before, the things that we really want to figure out is we want to figure out where the main points are. We want to know, obviously, the lowest point is going to be negative 3. The highest point is going to be positive 3, and then we're going to have zeros in between. So what our goal is one, to just kind of figure out where is the cosine of x equal to 1, or in other words, we're going to try and figure out where are our major points, okay? So here's what we're going to do. If I do the cosine of 0, the cosine of 0 is equal to 1. So that negative 3 changes it to negative 3. So cosine of 0 is equal to 1, but in this case it'll be equal to negative 3. So now, again, we'll get there in a minute. But then, you know, of course, we know that the cosine of pi halves is equal to 0. The cosine of pi is equal to negative 1. The cosine of 3 pi over 2 is equal to 0. And the cosine of 2 pi is equal to 1. What we're going to do now is we're just going to take what we know from this equation and we're just going to manipulate this a little bit. So if you think about it, we said the frequency is 0.5. So if the frequency is 0.5, then what that means is that it's going to take double as long for us to get to each of these special points. So we know that we're starting at negative 3. So it's clear that our function is going to start going up. And then obviously it's going to go through the 0 and then it's going to create a maximum here. So what we want to do is let's look at this and actually figure out, okay, if everything's going to take double as long, normally from us to go from 1 to 0 or anything to 0, it takes pi halves. Well, instead of it taking pi halves now, it's going to take pi. So you can assume then, because if the cosine of pi halves is equal to 0, if we put that 0.5 in there, then when I write this in, negative 3 cosine, and then instead of us just writing pi halves, if we do 0.5 double as long times pi, that's going to equal the exact same thing as we're getting over here. So therefore, it's going to be cosine, when we plug in pi, it's going to be 0 instead of pi halves. Again, the reason is because our frequency is 0.5, so it's going to take double as long to get to where we need to go. The same thing is true when we want to go to our next point, which is in this case going to be a positive 1. Again, the negative 3 is changing everything. So now we look at the pi. If you double that, that's going to be 2 pi. And instead of it being negative 1, it's going to be a positive 3 because this negative changes that. So we go to pi or 2 pi, and that's going to be at a positive 3. Now again, go backwards. Normally, the cosine of negative pi halves, so when we have our negative pi halves, it's going to be the exact same thing except it has to be doubled again. So negative pi halves would be 0. So now it's got to be negative pi for it to be 0. And then again, of course, negative 2 pi will be back up to where we're at a positive 3. And remember, all of your functions here should have the same look. It should still be a cyclical function that keeps kind of going up and down, up and down, up and down. So make sure that it still looks like that. Don't let this stuff confuse you too much. You can always use a calculator to check your work, but the big thing here is making sure that the frequency is going to kind of tell you how these main points that we know and that we use all the time, it's going to kind of show how those are always changing or how it's going to change on the graph. Okay, we'll always use these points as a reference point and then just figure out how quickly is it going to get to that normal point, and that's all dependent on what you're multiplying by. Okay, so we'll work on this certainly in class a little bit more. So the next part, is when we're given a graph, we want to be able to identify all the pieces of the graph and then be able to write an equation. And this can get a little bit tricky, but I think that this in some ways is easier to do than actually graphing without a calculator. So let's first identify the amplitude. So the amplitude here is going to be midway point is at 0 and it goes all the way up to 3. So therefore our amplitude is 3. Our frequency, if I could write, our frequency, we'll get to that in a minute because we're not going to be able to figure out our frequency until we know what our period is. So our period, again, our period is really simple. It's where does the graph start and where does it get to the exact same spot that it was? In other words, when did it complete a full cycle? So it goes down, all the way up, and then down again. So if you count that, you can figure out what your cycle is there, and it's labeled, you may not be able to see it, but it's labeled as 2. So therefore the period here is 2. Now if we wanted to figure out our frequency is just going to be 2 pi divided by the period. So it's exactly the opposite of figuring out the period when you're given the frequency. So at 2 pi divided by the period, so we do 2 pi divided by 2, so therefore our frequency is going to be pi. So now let's talk about writing the equation here. So clearly we have a, oh, and I apologize, the amplitude here, that's not a 2, or that's not a 3, that's a 2. So our amplitude is 2. You could probably figure that out. Maybe you can see it on your paper better than I see it on the screen. But so that's a quick fix there, no big deal. So clearly, when we write our equation, the first thing you want to do is you want to look for what's our function at 0. Because it's going through the origin, you can assume that we're using a sine function. The next thing you want to pay attention to is the amplitude. The amplitude is 2. So clearly, we have to have a 2 out in front. The next thing you want to look for is the graph reversed? In other words, is it flipped? Does a normal sine function go up at the beginning? Well, it does. Because it's going down at the beginning, we're going to put a negative out in front. Now we look for the frequency. The frequency is always going to be what's in front of our x. So the frequency is pi. So this is just going to be pi times x. And that's what your equation is. So once you have all these pieces of information, it's pretty easy to write an equation. Obviously, when we get to the next section, it gets a little bit more difficult, but this should be pretty straightforward. Identify which trig function you're dealing with, figure out the amplitude, is it flipped or not, and then the frequency times x. Okay, so down here, I want you to try this one on your own. Let's see how you do. In this one, you should have gotten an amplitude of 5 because it goes from 0 to 5. The period here is 4 because it takes from 0 to 4 for it to go through a full cycle. 1, 2, 3, 4. That's how you got that. So you started at a minimum, got to a minimum again. That'll tell you what a full cycle is. So therefore, we used the period to get our frequency, which ended up being pi halves. This allowed us to write our equation. So the amplitude was 5. It's cosine because we're not starting at 0. Okay, we're starting at a different value. The reason why it's negative is because it's flipped. Normally the cosine would start up at 5, so it's negative 5 cosine, and then we just put the frequency right in front of the x. So hopefully that makes sense. What I'm going to have to do is, I know that this is a longer video. I knew that it was going to be. What we need to do is start another video to do this example and then go from there. So click on the next video.